Hello there. In this video, we're going to talk about matrix operations. And this is going to lead directly into talking about image filters and how convolutions work within convolutional neural networks. Okay, so this is another tab within a few good things to know about Excel. The Excel file that I created to kind of expose people to these different functions. Some of the concepts that are covered, matrix operations, just briefly, image filters, convolutions, even talk a little bit about padding so you see one example of how that works. Now we'll shift over to Excel. As you can see here in the upper left-hand corner, we have a 3x3 matrix. Now, I can actually name it like I list in the steps, but we're just going to use the properties of some of these dynamic arrays throughout this example. So to determine it, we can actually just select the whole thing. So it's called matrix. We already named it. The matrix inverse, and we can select this whole thing, which is the variable matrix. Press enter. So there's the actual inverse of the matrix. One of the properties of a matrix inverse is if we do matrix multiply, so mmult again, we can choose this matrix, and then I'm going to just select the upper left-hand corner, add the hashtag, so I grab that whole dynamic array. Close parentheses, enter. So there we go, the identity function, ones across the diagonal, zeros everywhere else. And that's what you should get when you multiply a matrix by its inverse. There's also functions such as to transpose a matrix. I'm going to scroll up a little bit. It's just the function is transpose, and then we're just going to type it in, matrix. So this is going to swap some of these values along the diagonal. And then we can do a per element multiplication. So for this example, we want to do, let's go back up. We're going to take matrix, we're going to multiply it by transpose. Again, we can just add the hashtag or the number symbol, and that will grab the entire dynamic array. And if we press enter, what it's actually doing is it's taking each of these elements, like the one here, multiplying it by the corresponding one in the matrix that we started with. It's going to take the 2 here, multiply it by the 4. So it's multiplying corresponding elements within these two matrices to come up with a per element matrix multiplication. And again, to go back to the formula, that was just matrix, the variable, just times, and then this dynamic array, the transpose. And then here's another new matrix. Oops, get out of that function. Here's a new matrix, and we can actually do matrix multiplication of matrix, comma, and then we want to select this new matrix. Now this doesn't always work. So I say here the new matrix has dimensions of 3x4. You have to make sure that the dimensions of your matrices are such that they can be multiplied together. So a 3x3 multiplied by a 3x4 equals a 3x4. Also interesting, if you had a 3x100 matrix multiplied by a 100 by 4 matrix, that would also equal a 3 by 4 matrix. So the dimensions have to line up in order for them to be multiplied. Okay, so now we've kind of talked a little bit about how matrix operations work, and the important part there is really the per element multiplication, which is important when we get into convolutions and image filters. So rather than go straight to a 2D, which is this middle column that that I have here in this Excel file, I'm going to actually scroll in and let's focus on just a 1D example for a minute. So let's start. Let's pretend this is an image or a one-dimensional signal, if you will. In each of these different pixels or areas, we have 5, 5, 10, 5, 5. And how these convolutions work is that now you have a filter. So what I'm showing here is an average filter. I've got ones in each of these areas. I actually normalize this to 1, so you have 0.2 in each area. And what you end up doing is you take this value, 0.2, you multiply it by the initial values, and then you are going to sum those up to get a final output. And what happens here is this is the initial pixel that you are grabbing values from the surrounding area. You're passing it through this filter or convoluting it with this filter. And then in the end, you have a single value which replaces that 10 within the matrix. And that's how these image filters work. Essentially, you would run this filter, then you would slide it along every single value, again, replacing that value after you've done the calculation and it's been applied, to the local neighborhood. So now let's see what this looks like in 2D. So I'm going to scroll over. Here I created a 6 by 6 image. You can see the values 1 through 36. And then I use the conditional formatting option. For those of you that are interested, and this is one of the things that I think is actually pretty cool within Excel, you can highlight all of this, go up to conditional formatting, color scales, and you can select different color scales for your image, or for parameters. If you want to quickly get a visual of which parameters are greater or less than, here's again a white to green scale, but you can do a hot cold scale. Actually, this would be hot cold, red as the high, and it's just a quick visual way to kind of see the values within a matrix. So here we've got the image. You can consider that each of these is a different pixel with a different value. Here we have a filter. This is actually an edge filter, and what we have here, why it's an edge filter, is on one side of it, you're multiplying the values by a -1. On the other side of, again, the pixel that you're trying to get a new value for, you have +1. And then along this column are zeros. So 0 times any value is going to equal 0. So they're going to contribute nothing towards the final output. And so if we actually take, and let's look at what's actually happening here. This filter is going to be passed over every 3 by 3 region within the initial image. So if we look in this upper left-hand corner, what's actually happening there? Well, it's looking at this 8, and it's going to replace it with a value after running it through this edge filter. So we have this function called sum product. sum product, what it's going to do is it's going to do an element-wise multiplication. So 1 times -1, 7 times -1, 13 times -1, and then 3 times 1, 9 by 1, 15 by 1. And then it's going to sum all of those values. And so when you sum those values, you get 6. And then if we get out of this, if you look at any of these other areas, it's still applying the same filter, but now it's shifted over 1. And then it will continue to shift until it runs out of room. And then, but here, as well as in the first example, the first pixel, you're going to return a 6. And this is just the way that I've structured these numbers. Obviously, if there were different numbers, in particular, it's trying to highlight, any vertical edges. So if there were vertical edges here, it would really hone in and would show a very different value. So would center on the fact that the pixels on one side of the vertical edge were very different than the pixels on the other side of the vertical edge. So this is just how these image filters work. And now we can go down. What padding refers to is, well, if you notice from up above, we started with the 6 by 6, and then the image actually shrank to a 4 by 4. And that was because it's hard to apply a 3 by 3 filter when you're centered on one of the pixels along the border. And so what they often do is you might pad the outside with zeros. So here we can pad the outside with zeros. And when we do that, now the upper left-hand corner, you can see we can use the filter in this upper left-hand corner. So we still have the original 6 by 6 image. It's just how do we account for the fact of there not being values outside the image. And one of the options is just to replace those values with zeros. And you can see what this looks like now. We still have the 6s on the interior part, but when you replace the outside pixels with zeros, now you're actually getting values, and it's returning an image that is the same size as the initial image that you had. So it's a 6 by 6 image. Say this is interesting. This is often used in convolutional neural networks. So this gives a brief introduction to how these convolutions and image filters work within Excel.